This is R.D. Sharma solution we are taking. This is the chapter of probability and the exercise is third exercise. Now A and B are two events such that twice of PA is equal to PB is equal to 5 by 13. A double equality is there. PA by B is also given, which is 2 by 5. We have to find PA union B. So whenever the probability is coming, PA union B is PA plus PB minus PA intersection B. That we can employ here. This PA by B. This is what we need to find out. And for that, we need the intersection in the numerator. That is PA intersection B in the numerator. And denominator will be PB. Now PB is already given 5 by 13. That can be written in the denominator until we find out PA intersection B. So this PA intersection B needs to be computed because PA union B also needs to be computed. But this PA by B is already given, which is 2 by 5. So multiply across. So PA intersection B comes to be 2 by 5 into 5 by 13. So this is 2 by 13. So PA intersection B we have achieved. Now the formula which I was telling in the beginning, PA union B is equal to PA plus PB and minus the intersection one, A intersection B. Now let's put all these values. PA is can be computed now, but PB is given directly. So PB is 5 by 13. PA intersection B is also known, so let's write it here 2 by 13. Now from here, as I was suggesting that this is the double equality, so twice of PA is equal to 5 by 13. That is the twice of probability A is already given as 5 by 13. So the probability of A be computed, just bring 2 in the denominator, it will be 13 into 2, which is 5 by 26. Now we can write it here 5 by 26. So this can be computed. It's a simple computation. It will come as 11 by 26. Now this is how it needs to be done. You're already aware of all these. And next one. So PA is given, PB is given, and PA union B is given. PA intersection B has to be computed, PA by B is, and P by B, B by A has to be computed. So what is the formula we are going to employ here? The first one is A intersection B, PA intersection B. This will become PA plus PB minus PA union B. This will be PA union B, not intersection. I'll just change it. PA is already given to us 6 by 11. PB is also known, which is 5 by 11. Then we have PA intersection B. That I need to change it to PA union B, which is actually 7 by 11 given in the question. So 6 plus 5 is 11. 11 minus 7 is 4. 4 by 11 has come. So PA intersection B is equal to 4 by 11, which is the first one which we were expecting. Now second one is PA by B, and second and third will do it together side by side. So second and third PA by B and PB by A can be computed. So this is PB by A. So this equals PA by B is PA intersection B, and PB by A, PA intersection B again will come in the numerator, both of them. But whichever is already done, that is PB comes denominator. Here PA comes in the denominator. Again, PB is a slight mistake. I'll just correct it. PA intersection B we have already computed 4 by 11. PB is already given, which is 5 by 11. So this comes out to be 4 by 5. So in this case, PA intersection B is 4 by 11. PB is, no, it is PA as I suggested. So this is 6 by 11. 4 by 6 is 2 by 3. Now this is how you need to write all of these. It's a very straightforward question because simple formulas are being employed here. Now we have 3 questions alike. Similar. So a coin is tossed 3 times. Find PA by B in each of the following. A heads on third toss, B heads on first 2 tosses. Now we need to make the events, and events will be exactly similar to what is given in the question. So A can be heads on third toss, that we can make heads on third toss. This head on third toss became the first one, A event. The second event, which is B, is heads on first 2 tosses. So heads on first 2 tosses. Now whenever we toss a coin, either head or tail will come. Now this coin is tossed 3 times. So 2 possibilities are there. 2 to the power 3, 2 raised to the power 3 will be 8. So there are 8 total possibilities. So we'll just take this heads on the third toss, as there are 8 possibilities, but we are only interested in heads on third toss. So the third toss is now fixed. H, 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 H. Now the first 2 can be the combination of head and tail. So it can be head, tail, tail, head, head, and tail, tail. So these are 4 options here. Let's write it here. See, the last one is already fixed. Other 2 the first one and second one can be arbitrary. It can come either head or tail, both head, both tail. So these are 4 possibilities we have. So HTH or HHH, start with HHH. Then we have HTH, head, tail, head. Then we have a tail, head, head, and finally tail, tail, and head. Now in the similar fashion, the even B, heads on first 2 tosses. So when you fix head on first 2 tosses, only possibility is either head will come or tail will come in the third toss. So this B event will have these content HHH and HHT, that is head, 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 and head, head, tail, because the first 2 tosses has been fixed as heads. Now what is the intersection between A and B? You just have to find the common element of these 2 sets. So HHH we got, so just write HHH. Do we have HHT? We cannot have HHT in A, because in the first event H should or head should come in the last. But here tail is there, so only one value of one content or one element of the sets are intersected, they are only common. So the probability of A by B, that is probability of getting heads on third toss, when it is known that the heads on first 2 tosses has already come. So this will be equal to, probability is nothing but the number of elements in that set. So NA intersection B divided by NB. So we don't have to worry about the number of elements in A. And A intersection B is what? It's only 1. Only 1 we got. But NB is 2. 1 and 2. So this is how this will be done. And these are all the combination questions. Basically, if you can make this one, the probability finding is quite easy. A coin is tossed 3 times. Find P, A by B in each of the following. Now A is given, B is given. A is at least 2 heads. And B, which is at most 2 heads, has already happened. So I'm writing the sets here. A is at least 2 heads. So at least 2 heads we have written. I'm just writing the same thing. No changes. But we will make the set here only. The B is at most 2 heads. That means not more than 2 heads can appear. So at most 2 heads. So at least 2 heads means you need to have 2 heads. It can come in any order. The coin is tossed 3 times. So the first and second come as head. The first and last can come as head. The second and third can come as head, and all of them can be head, because it is saying at least 2 heads should come. It is not saying that all the heads cannot come. So HHH is all the heads have come. Now coming to at most 2 heads. What does it mean? So there cannot be more than 2 heads. There can be no head. That is also a possibility. But maximum head possibility is only 2 heads, because head cannot come. The only thing here is head cannot come. So let me reiterate again the concept. For tossing a coin, the result can be only head or tail. So 2 possibilities are there, and it is tossed 3 times. So 2 to the power 3, 2 raised 3 is 8. So the total possibilities is 8. Now HHH you have to just subtract from at all the sample space. So all the sample space HHH cannot come, because at most 2 heads can come. All the 3 heads cannot come. So we have tail, tail, tail. So all these 7 except HHH, I am writing all of it. So tail, 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 head, tail, head, tail, head, 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 tail, tail, head, tail, head, head, tail, head, tail, tail. 1, 2, 3, 4, 5, 6, 7. 7 has come, because we have eliminated the HHH, because at most 2 heads can come. 3 heads cannot come. Now we'll use the same concept here. PA intersection B first of all. And probability is nothing but the number of elements in that probability set. What is A intersection B? The elements of the 2 sets which are common, or the element which is found in A set also and simultaneously in the B set also. So HHH will not be in the B, and so all of these are there. Only HHH is not there. So 1, 2, 3, HHT, HTH and THH will come. So HHT I am rounding, HTH I am rounding, and THH I am rounding. So there are 3 elements which we found simultaneously occurring in both these 2 sets. So let me write it: HTH, head, tail, head, tail, head, head, and head, head, tail. So in all there are 3 elements. Actually we just need the number. So 1, 2, 3. Number of elements in the A intersection B is probability of A intersection B. Not probability, I'll just compute it, but it is the number which we employ in computing the probability. So PA by B is PA intersection B divided by PB. That is NA intersection B divided by NB you have to find out. And in A intersection B, I just told you that it is 3. NB is the number of elements in B. I told you the H cannot come. All others, that means 8 minus 1, 7 elements can come. So 3 by 7 is the required probability. So this is how you're going to solve it. And I told you the concept also. Let's write the concept also on the right. That will be better. A coin is tossed 3 times. Find probability PA by B in each of the following. Now this is similar to this one. So A and B, I'm not writing it. You have to write it. Please remember. A and B, I'm just not writing because it is already given in the question. At most 2 tails and at least 1 tail. So what A will have? At most 2 tails. That is 3 tails cannot come. At most 2 tails means maximum 2 tails can come. 3 tails cannot come. So TTT will not be there. And B set says that at least 1 tail. Means HHH cannot come. At least 1 tail means all the heads cannot come. That is the whole idea about this question. So at most 2 tails, TTT cannot come. At least 1 tail, HHH cannot come. So we have 7 elements. So in all there will be 8 combinations or 8 elements in the set. Just remove TTT and write all the 7 combinations except TTT. So I'm writing all of them TTH. Whenever I'm saying T, it's tail. Whenever I'm saying H, it is head. So TTH, THH, HHT, THT, HHT, HTT, HHH. Let's use the comma here. Now what is B? At least 1 tail. That is, all the heads will not come. It is 1 tail. So you just remove HHH and write all the other 7 which are possible. So TTT, all the tails, TTH, THH, HHT, THT, HHT, HTT. Now let me make the round brackets followed by the commas in between, and the comma between this TTH also. Means all of them needs to be understood that in an event there are different elements which are actually the experiments. Now what is A intersection B? Now you just need to find out the values which are common in these 2 sets. So we have TTH, yes we got it. THH, yes we got it. THH. HHT is also there. So you can write this HHT here. THT is there, so write THT. HHT is there, you can write this HHT also. Now in the first one HHH is there which is not found in B, and in B TTT is found which is not there present in A. So we have reached up till HHT. Now HTT is also there. So in all, how many elements are there in this A intersection B? 1, 2, 3, 4, 5, 6. So I'm just writing this. Comma is very important. Braces is important just to represent it as a set. Now this NA intersection B is needed for the probability. 6 numbers are there. 6 elements are there in A intersection B. So probability of A by B is probability of A intersection B divided by probability of B. And this is nothing but number of elements in A intersection B divided by number of elements in B. What is an A intersection B? It's 6. What is number of elements in B? There are 7. Except HHH, all of the elements of sample space will be present here. Say 8 minus 1 is 7. 6 by 7 is the probability of this question. Let me tell you again, in a coin, head and tail can come. So there are 2 possibilities. Since this coin is tossed 3 times, 2 raised 3 is 8. So there will be 8 possibilities that will arise. Now let's see a formal way of solving it. If you are doing it by yourself, this is the reference you should consider. This question will be taken in the next discussion. And then thank you so much. Have a good one.